Imagine being on a boat in the middle of the ocean, surrounded by an endless blue expanse stretching beyond the horizon. Suddenly, the water beneath your feet begins to bubble, and something massive emerges from the depths. Legends speak of creatures capable of dragging entire ships into the abyss, leaving sailors with only one name to describe them. For centuries, this monstrous marine figure fueled the fears and imaginations of those who dared to venture into the open sea. Accounts of enormous tentacles capable of enveloping entire vessels and stories of unexplained disasters led many to consider it more than just a myth. But what truth lies behind these tales? Could the ocean depths conceal truths far more terrifying than we dare to imagine? Today, we dive into the origins of a legendary creature and the potential realities that shaped its fame. This is the story of the feared Kraken, though it may not have been exactly as we picture it. However, one thing is certain: the depths of the ocean hold secrets as fascinating as they are terrifying. To understand the origins of these myths, we must go back millions of years, to a time when the ocean was ruled by titans with gigantic tentacles, the prehistoric cephalopods. These creatures, even larger and more formidable than their modern relatives, played crucial roles in their ecosystems, becoming some of the most feared predators of their time. Cephalopods are one of the oldest groups of animals still in existence. They first emerged about 500 million years ago during the Cambrian period, long before sharks, reptiles, mammals, or even insects appeared. These ancient ancestors evolved from mollusks with unique shells, quickly becoming pioneers of the seas. What made them truly revolutionary was the development of tentacles and arms equipped with suction cups, perfect tools for interacting with their environment in entirely new ways. Their evolutionary success was so remarkable that after the Ordovician period, they diversified into an incredible array of forms and sizes. To date, more than 30 different genera of cephalopods from that era have been identified, each adapted to a specific ecological niche. In their early days, these cephalopods were not yet colossal in size. However, they quickly began to establish their dominance in the oceans, paving the way for the giants that would inspire the legends of the Kraken. As we explore the stories of sailors and their accounts of sea monsters, we also look back at ancient oceans where extraordinary creatures rewrote the rules of survival beneath the waves. The first prehistoric krakens were not products of human imagination, but real creatures that dominated the seas. A family of nautiloids known as Endocerids left a lasting mark on marine ecosystems. With massive bodies and straight cone-shaped shells, these predators inhabited nearly every ocean in the world, though they were particularly abundant in the shallow equatorial seas of the Cambrian period. Thanks to their extraordinarily powerful tentacles and arms, Endocerids were not only the giant cephalopods of their time, but also the largest animals on the planet. Among the most notable members of this family were the genera Camaracaris and Endocerids, which together encompass more than 50 species. Both lived during the same period and in similar regions, sharing very similar anatomies. The main difference was that Endocerids had a more textured shell, which has caused some confusion when classifying certain giant fossils that have been recovered. Although it is not entirely clear which genus reached the greatest dimensions, current estimates suggest their maximum shell lengths could reach up to 9 meters. Some reports propose that certain individuals of Endocerids, an exceptionally large species, might have been even more imposing, though this remains unconfirmed. Moreover, these measurements only account for their shells. When including the soft body extending beyond the shell, their total length could have increased by an additional 16%. This means that, while soft tissue rarely fossilizes well, these predators might have been even larger than we currently imagine. If you like what you see, don't forget to subscribe. We have set the goal of reaching 10,000 subscribers before the first half of this year, and with your support, we can achieve it. Join this community and let's make this channel grow together. Even with just their shells, Endocerids rivaled modern colossal squid in length. What's even more impressive is that if we exclude the long tentacles of the giant squid, which make up a significant portion of its length, Camaracaris and Endocerids were more than twice their size. Additionally, their calcium carbonate shells made them significantly heavier. The largest Endocerids could weigh up to 1 ton, whereas modern giant squid only reach around 0.3 tons, and colossal squid peak at approximately 0.5 tons. With such size and mass, Endocerids firmly established themselves as the apex predators of their time. Only two other animals from that era came close in size: certain sea scorpions and the peculiar arthropod known as Anomalocaris. However, neither posed a threat to an adult Endocerids. In fact, it's likely that these animals were prey to the massive cephalopod. How did these prehistoric krakens hunt? Despite their shells limiting their mobility, they are believed to have been expert ambush predators. They likely hid on the ocean floor, patiently waiting for their prey to come within range before striking with their powerful arms and dragging them toward their sharp beaks. While no intact beak has ever been found, paleontologists speculate that, like modern cephalopods, Endocerids had fibrous, chitinous jaws surrounded by strong muscles, granting them an impressive bite force. Their most common prey included trilobites, which were abundant on the seafloor and the perfect size for consumption. However, their diet was highly varied and included arthropods, mollusks, fish, and even other cephalopods. Despite their limited maneuverability, Endocerids were surprisingly fast. Like modern squids, they used a jet propulsion system, expelling water at high speed through large funnels, allowing them to move quickly when needed. This mechanism, combined with their arsenal of tentacles and sharp beaks, made them relentless predators and the undisputed rulers of the prehistoric seas. Fortunately for other marine creatures, the reign of the Endocerids over the oceans was relatively short-lived. Approximately 455 million years ago, near the end of the Ordovician period, Earth entered one of its Big Five mass extinction events, the late Ordovician mass extinction. According to scientists, this event was likely triggered by an intense glaciation, which caused a dramatic drop in sea levels and significant shifts in global temperatures. These environmental changes led to the complete extinction of the Endocerid family and a severe decline in the diversity of cephalopods overall. Following this catastrophic event, cephalopods entered a period of reduced size and influence that lasted for more than 200 million years, spanning the Silurian, Devonian, Carboniferous, and Permian periods. During this Kraken drought, cephalopods were gradually overshadowed by sharks and other fish, which became the dominant large predators in the oceans. Although this era marked a time of less prominence for giant cephalopods, it was crucial for their evolutionary history. During this time, unusual and alien-looking cephalopods with bizarre shell shapes emerged. New groups, such as ammonites and belemnoids, also evolved during the Devonian, leaving a significant mark on the fossil record. It was also during this time that cephalopods developed an adaptation that would forever change their defensive strategies: ink sacs. This feature, which first appeared in the Carboniferous, allowed cephalopods to blind and confuse predators, a strategy that remains highly effective and is still used by modern species today. While the species from this era never reached the colossal sizes of their Ordovician ancestors, some managed to become what could be called mini-krakens. One notable example is the genus Rhinoceros, a pseudo-orthocerid that lived approximately 325 million years ago during the Carboniferous period. Rhinoceros was not directly related to the Endocerids, but shared some similarities, such as its long, straight shell, which housed most of its body. This genus inhabited equatorial waters in the vast oceans of Panthalassa and Tethys, preferring warm, shallow seas. Some individuals of Rhinoceros could reach lengths of up to 2.4 meters, excluding their soft tissues. While not as impressive as the massive Endocerids, they were still quite large by modern standards. However, paleontologists believe that these cephalopods were not apex predators and likely lived in a manner similar to modern squid, preying on small fish and arthropods. During this time, new predators began to dominate the oceans. The Eugeniidontiformes, a group of fish with uniquely toothed jaws designed for cutting soft tissue. These fish may have posed a serious threat to Rhinoceros and other cephalopods of the Carboniferous. After millions of years of relative quiet for cephalopods, everything changed during the Mesozoic era. This revival may have been triggered by the Permian-Triassic mass extinction, the most devastating event in Earth's history. This extinction wiped out nearly 96% of marine species, allowing prehistoric oceans to undergo a complete reset, creating new opportunities for cephalopods to thrive. As the Permian period ended and the Triassic began, ammonites emerged as dominant players in the oceans, becoming an incredibly abundant and diverse group. Among the many species and families that arose, the Cladiceridae stood out, particularly for their impressive size. Some of these ammonites had shells reaching up to 1.7 meters in diameter. For perspective, the nautilus, the largest shelled cephalopod alive today, has a shell diameter 17 times smaller. This massive size not only offered exceptional protection against predators, but also allowed these ammonites to spread across Triassic oceans, inhabiting a wide range of marine environments. Despite their impressive size, the Colossal were not fearsome predators. Most paleontologists believe they fed on small, slow-moving prey like crustaceans, plankton, ostracods, and possibly even marine vegetation. They left the role of apex predators to massive ichthyosaurs, which dominated the Triassic seas. However, cephalopods, particularly ammonites, would ultimately outlast their Triassic rivals. As the Mesozoic progressed, ammonites not only became more abundant, but also began increasing in size. Meanwhile, ichthyosaurs gradually declined in size and were eventually replaced by other equally formidable marine predators. By the Jurassic period, ammonites had surpassed their Triassic predecessors in many ways. One notable example is the family Tusoteuthis, which included ammonites significantly heavier than any previous cephalopod. A remarkable fossil from this family, belonging to the species Tusoteuthis tahoense, was discovered in New Zealand. Its shell measured 1.42 meters in diameter. While not as large in diameter as the Cladicerated shells, its structure was denser and more robust, allowing it to weigh between 1,300 and 1,500 kilograms. This weight exceeded even the heftiest of the ancient Endocerids. Interestingly, despite being heavier, paleontologists believe this ammonite was much faster. Its shell morphology suggests it might have been an active predator. However, due to the scarcity of fossils, little is known about its behavior. This scarcity could be attributed to its preference for deep waters, where conditions for fossilization were less favorable. Not only did ammonites grow larger during the Jurassic, but other cephalopods, like the belemnites, also experienced significant increases in size and weight. One fascinating example is the genus Tusoteuthis, which lived along the coasts of what are now Europe and Asia during the early and middle Jurassic periods. While it closely resembled modern squids and belonged to the same subclass, Tusoteuthis had several key differences. It lacked tentacles and featured an internal skeleton that formed a protective cone. The largest specimens of this genus reached lengths of 3.1 meters, making it the largest belemnite ever recorded. If it were alive today, Tusoteuthis would be considered the fourth longest cephalopod on the planet. However, its size wasn't its only intimidating feature. Its arms were covered with up to 800 sharp hooks, perfect for impaling or gripping prey such as fish and small marine mammals. Additionally, it possessed a strong, sharp beak capable of delivering surprisingly powerful bites. Tusoteuthis was a fearsome predator, but it still wasn't the largest creature dominating the oceans at the time. Imagine a prehistoric ocean where not one, but three cephalopod titans shared the waters. This epic scenario unfolded during the Cretaceous period in the western interior seaway, a vast body of water that split North America in two. This marine realm wasn't just a habitat for impressive creatures, it was a stage for an intense struggle for survival. Among these titans were Tusoteuthis, Endocerids, and Parapuzosia, rightfully earning the title of the Krakens of their time. One of the most fascinating cephalopods of this era was Tusoteuthis, a creature that challenges conventional expectations. Unlike its ancient relatives with external shells, this giant was entirely soft-bodied, much like modern squids. For a long time, scientists believed it was related to vampire squids or today's colossal squids. However, recent research suggests something surprising. Tusoteuthis was more closely related to octopuses. Picture it as a massive cuttlefish without tentacles, but with a muscular, robust body. Early estimates placed its length at up to 11 meters, but the most recent data suggests it likely reached around 3 meters, a size that still made it a formidable predator. Its body was built for speed and precision. With a streamlined mantle and lateral fins, Tusoteuthis could move swiftly and efficiently, stalking prey such as fish, small marine reptiles, arthropods, and even seabirds. Its versatility allowed it to hunt in both deep and shallow waters, solidifying its role as an apex predator in the western interior seaway. Endocerids, another colossal cephalopod of the Cretaceous period, roamed the same seas as other marine giants, yet carved out its niche as one of the most enigmatic predators of its time. Like Tusoteuthis, Endocerids lacked an external shell, making it more similar to modern squids and octopuses, though its evolutionary story continues to puzzle paleontologists. Initially mistaken for a giant squid due to remnants of its internal pen, further research revealed a surprising fact. Endocerids was more closely related to cuttlefish. This implies it may have possessed a calcified internal structure to aid in buoyancy control, granting it an edge in navigating different ocean depths. Estimates suggest Tusoteuthis measured between 4 and 6 meters in length, placing it among the marine titans of its time. Its robust muscular body, combined with long, powerful fins, enabled it to move with agility and precision, ideal for ambushing prey. Its menu likely included fish, crustaceans, and even small marine reptiles. What makes Tusoteuthis truly fascinating is its ability to fill an ecological role akin to modern apex predators, despite belonging to a vastly different evolutionary lineage. Hunting in deep waters and patrolling near the surface, it was an adaptable predator, securing its dominance in the marine ecosystems of the Cretaceous. Imagine a hybrid of a giant cuttlefish and a robust squid, prowling the oceans with lethal precision in a world teeming with marine monsters. Tusoteuthis not only survived, but thrived in a challenging environment, showcasing the remarkable adaptability of cephalopods. As imposing as Tusoteuthis was, there was another creature in the western interior seaway that dwarfed it in size: Prehistoric, the undisputed king of the ammonites. This cephalopod, a member of the Desmoceratidae family, holds the title of the largest invertebrate ever to exist. The discovery of an incomplete shell in Germany transformed our understanding of this titan. Paleontologists estimate that, if complete, its shell would have spanned an incredible 3.5 meters in diameter. When uncoiled, this perfect spiral would reveal a total body length of up to 18 meters, surpassing even modern giant squids. Not only was Prehistoric long, but it was also massive. Weighing approximately 1.5 tons, nearly half of its weight came from its shell. This structure, in addition to offering protection, acted as a ballast, keeping the creature stable as it cruised through the ocean depths. The western interior seaway wasn't merely home to Tusoteuthis, Tusoteuthis, and Prehistoric. It was a realm shared with marine reptiles like mosasaurs and plesiosaurs, creating an ecosystem where predators vied for supremacy. These prehistoric creatures remind us that the history of the oceans is filled with real-life monsters that rival even the most vivid imaginations. Who knows what other wonders remain buried in the depths of time? For now, the fossilized remains of these titans give us a glimpse into an era where the seas were ruled by true giants. Due to its enormous size, paleontologists believe that Prehistoric may have had a highly varied diet, acting as an opportunistic predator feeding on marine reptiles, fish, and other vertebrates. However, some researchers suggest it might have been more of a peaceful giant, favoring a diet of plankton or marine vegetation. The fact that such giants coexisted within a single ecosystem is a remarkable testament to the marine biodiversity of the late Cretaceous. Yet this was not the only region to host giant cephalopods, as other parts of the world also served as havens for these colossal creatures. Ironically, given Japan's cultural trope of sea monsters attacking its shores, paleontologists there unearthed 2 prehistoric cephalopod beaks that left them astounded. Both beaks were larger than those found in modern giant and colossal squids, with the largest of the 2 being roughly twice the size of any known giant squid beak. Based on these findings, scientists concluded that the beaks belonged to 2 different genera of prehistoric giant squids named Haberoteuthis and Tusoteuthis. These cephalopods were undeniably massive, but researchers do not necessarily believe that the beaks indicate body sizes twice as large as those of modern colossal squids. Instead, they suggest the beaks reflect exceptionally powerful and wide bites, enabling these squids to become top predators in their environment. The only limitation would have been the size of their prey, as paleontologists believe these squids were among the largest marine creatures in their oceans. Of the 2, Tusoteuthis was slightly larger, though even it did not reign as the king of the seas during its time. Paleontologists later discovered another beak in Japan that dwarfed both earlier fossils. Its genus remains unidentified, and whether it represents a new species of cephalopod is unknown. To add to the mystery, no size estimates have been provided for this enigmatic prehistoric kraken. However, one thing is certain: Whatever it was, it did not make the seas any safer. Could a monstrous cephalopod have ruled the oceans 215 million years ago? That is the intriguing idea behind the legend of the Triassic Kraken, a hypothesis as controversial as it is fascinating, transporting us back to the Triassic period, long before dinosaurs reached their peak. The story began with the discovery of the remains of 9 giant ichthyosaurs clustered in a relatively small area. According to one paleontologist, these creatures did not die of natural causes or a catastrophic event, but were hunted and meticulously arranged by a gigantic cephalopod that lived in the region. In an act of bold speculation, the paleontologist proposed that this kraken must have been around 30 meters long to face such gigantic marine creatures. If true, this would make it the largest cephalopod ever known, far surpassing the modern giant and colossal squids. The most striking detail of his theory was the idea of an underwater cemetery, where the supposed kraken had deliberately placed the remains of the ichthyosaurs. According to this hypothesis, the marks on the bones and the arrangement of the fossils were evidence of intelligent, premeditated behavior. As thrilling as this story sounds, the scientific community almost immediately rejected it. The problems were clear: lack of cephalopod remains, no direct fossils of the supposed kraken were found in the area. More plausible alternative explanations: the ichthyosaurs could have died due to a massive stranding event or simply through erosion, which left them buried together. Physical difficulties. Even a 30-meter cephalopod would have faced serious challenges in hunting an ichthyosaur, let alone 9 at the same time. Years later, a cephalopod fossil was discovered at the same site. Although it was just a simple beak, only 5 centimeters long, the paleontologist reignited the controversy. According to him, the beak belonged to a gigantic cephalopod, probably the size of a bus. However, the evidence did not support these claims. The size of the beak was similar to that of a modern colossal squid, suggesting an animal of respectable size, but far from being a mythical monster. While this hypothesis remains viewed more as a curiosity than reality, it continues to raise fascinating questions. How large could prehistoric cephalopods have grown? How many unknown species remain hidden in the fossil record? What is clear is that the oceans of the past were teeming with extraordinary creatures, and perhaps deep within those prehistoric waters, krakens existed that were more impressive than we can imagine today.